Hi guys, today let us discuss about reflection and the properties of waves. The first question on your mind right now is, what is reflection? The direction of propagation of energy of a wave will change when the wave is incident on a surface or a boundary. The wave bounces off or gets reversed. This is known as reflection. So guys, what do you need to know about reflection? The laws of reflection, the changes after reflection, the pattern of wavefronts after reflection, and also the application of reflection are the things that you need to know about reflection. First, let us talk about the laws of reflection. First and foremost, let us look at these two ray diagrams and then discuss about the laws of reflection from these two ray diagrams. In the first ray diagram, we can observe circular wavefronts, and in the second diagram, we can observe plane wavefronts. So what are wavefronts? A wavefront is defined as a surface over which the phase of the wave is a constant. It means in a particular wavefront at a given moment of time, all particles of the medium are undergoing the same motion. There are two types of wavefronts, which are the circular wavefronts and the plane wavefronts. So what is common in both ray diagrams? We have an incident ray and a reflected ray in both the ray diagrams. And we also have angle of incident, which is alpha, and angle of reflection, which is beta, in both the ray diagrams. And we also have a normal, which is a perpendicular drawn to the reflecting surface. From these two ray diagrams, we can discuss about the laws of reflection. So let us get back to the laws of reflection. Here we have the laws of reflection. In the first law, it states that the angle of incidence is equal to the angle of reflection. So what does this mean? When an incident ray comes and hits on a surface, it reflects back towards the medium. And in this instant, we would have the angle of incident to be equal to the angle of reflection. And in the next law, it states that the incident wave, the reflected wave, and also the normal all lie in the same plane, which means all these incident wave, the reflected wave, and the normal are in the same plane. Now let us discuss about the changes after reflection. So what happens when an incident ray strikes on a surface and reflects back towards the medium once again? We would observe changes after reflection. First, we can see the changes. The direction would be changed, and here you can see what remains unchanged. The wavelength, the frequency, and the velocity of the wave would remain unchanged, and also the amplitude of the wave may or may not change depending on what type of reflector is used. If we have a really good reflector, we would observe that the incident ray and the reflected ray would have the same amplitude. So guys, what do you need to know about the pattern of wavefronts after reflection? The plane wavefronts obey laws of reflection. So what happens in circular wavefronts? Here you can observe that these are circular wavefronts and this is a reflecting surface. What happens here is that the object distance would be equal to the image distance. Here the center is the object, which is the source of the wave, and here the center is the image of the wave. The image of the wave appear to come from this particular center here. So what we know about the speciality here is that the object distance u is equal to the image distance v. So the distance from this reflecting surface to the image is equal to the distance from the reflecting surface to the center which produces the wave. So what happens here? The wavelength remains unchanged in this particular circular wavefront instance. Here we only discussed about surfaces that are planar. We also have surfaces that are curved. So we have instances where reflection occurs in curved reflectors as well. You guys must be wondering what are the applications of reflection. The sonar or the sound navigation and ranging of ships use sound waves to measure the distance and speed of underwater objects. The stethoscopes used by doctors is also an application of reflection of waves. The echo that we hear from sound waves after being reflecting or bouncing back off a surface is also an application of reflection of waves. Even bats use the phenomenon of reflection in order to find the path in the dark after sending ultrasound pulses from them. Even water waves shows the phenomenon of reflection. We will discuss about the reflection of light in the optics section. You will be facing two other terms when talking about reflection of waves. So what are these two other terms? They are said to be rigid reflection and soft reflection. Let us look at the following demonstration to observe what are rigid reflection and soft reflection. First, let us look at the rigid reflection. Here we have two fixed ends, one being the hand and the other being the end where it is attached to. When we send a wave pulse from our hand, it would reach the other end, which is the fixed end, and then it reflects back towards us, and then again it would reflect from ourselves towards the fixed end. What happens here? You can observe that the direction of the wave pulse would change after it is been hit on a fixed end, which means if we have initially a wave pulse traveling in the left hand side, it would change direction to the right hand side after being hit on the fixed end. This happens vice versa too. So what this means is that whenever the incident wave pulse is reflected back, it is out of phase to the incident wave pulse. These types of fixed end reflections are termed to be rigid reflections. Now let us talk about soft reflection. The point that we hold the rope is said to be the fixed end, and the point that the rope and the string is attached is said to be the soft end. What happens here is that the incident wave pulse and the reflected wave pulse after it is been hit on the soft end, which is the end where the rope and the string are attached to each other, we would have a soft reflection. But you must have noticed the transmitted wave, which is the wave traveling after passing the soft end, which is the end where the rope and the string are attached to each other, we would have a higher amplitude and a higher wavelength. That is a small briefing about the rigid reflection and soft reflection. So guys, that's about reflection of waves. Let us discuss about refraction of waves in our next video. Hope you guys enjoyed today's video. Have a nice day.